Hello students, I hope that you are good, well and fine. In today's session, we will be seeing some properties of definite integrals. Okay, so let's see. So first property or P naught is a definite integral from a to b fx dx is equals to definite integral a to b ft dt. What this property says? This property says instead of x you can use t, you can use u, anything you want. Okay, you can substitute your this variable x, okay, like t, like u, whatever you want. Okay, so I hope it is clear. Now p1 property, definite integral a to b fx dx can be rewritten as minus b to a. Here definite integral is going from b to a. Here is definite integral going from b to a. Okay, that's why when we interchange our limits, lower limit becomes upper limit and upper limit becomes lower limit, then there is an extra minus sign. Okay, as you can see. So definite integral a to b fx dx is equals to minus of definite integral b to a fx dx. Simple. In particular, definite integral a to a, the same point to same point, fx dx will be always 0. Okay, now p2, definite integral a to b can be rewritten as definite integral a to c fx dx plus definite integral c to b, where c belongs to what? This interval. C belongs to in this interval. C must be somewhere here. Okay, in between a and b. Okay, now p3 says definite integral a to b fx dx is equals to what? Definite integral f of a plus b minus x. This thing, this means upper limit plus lower limit minus x. Okay, now definite integral from 0 to a fx dx will be what? Definite integral from 0 to a, sum of these a plus 0 minus x. We used above property, p3 property here. Okay, now p5 property, definite integral 0 to 2a, definite integral 0 to 2a fx dx can be rewritten as definite integral 0 to a fx dx plus definite integral 0 to a f of 2a minus x dx. This thing. Okay, clear? Okay, now let us move next. Next property p6, definite integral 0 to 2a fx dx can be rewritten as 2 times 0 to a fx dx. Okay, only when f of 2a minus x is equals to f of x. We are using the above property, property 5, p5. Okay, if f of 2ax is same as fx, then you can add them, you will get this. If it is if it is minus x minus f of x, then the sum will be 0. This means definite integral 0 to 2a fx dx will be just 0. Okay, now property p7, first part, definite integral minus a to a fx dx is same as twice of definite integral 0 to a fx dx, only when if f is our even function. Only when f is our even function. Okay, okay, now that is f of minus x is same as fx. Now second part, definite integral minus a to a fx dx is 0 when f is odd function. Odd means f of minus x is equals to minus of fx. Okay, clear? Okay, let's see their proofs. So for property P0. Just substitute x is equals to t, then dx will be dt. Then just replace it. What you will get? You will get a to b f of t dt, the same thing. So this proof is clear. Okay, now for P1, let capital F be antiderivative of small f. Okay, then use second fundamental theorem of calculus. We have definite integral a to b fx dx is equals to capital F of b minus capital F of a, which is equals to minus of capital F of a minus capital F of b. Okay, which is equals to minus definite integral b to a fx dx, as you can see. Okay, we just used second fundamental theorem of calculus. That's it. Okay. Now, if a is equal to b, then what will happen? Now, as you can see, if a is b, then definite integral a to a, definite integral a to a will be 0. I hope it is clear to you. Okay, you put b, a is equals to b, so here you will get definite integral a to a fx dx is same as minus a to a fx dx. Okay, this means add them, take this right hand side to the left hand side, you will get what? Twice of definite integral a to a fx dx is equals to 0. Then divide by 2 both the sides, you will get this result. Okay, clear? Now property 2. Property 2 says definite integral a to b fx dx is same as definite integral a to c fx dx plus definite integral c to b fx dx, where c belongs to in between a and b. Okay, so let capital F be an antiderivative of small f, then definite integral a to b fx dx can be rewritten as capital F of b minus capital F of a using second fundamental theorem of calculus. Okay, now definite integral a to c fx dx will be f of c minus f of a. Okay, now what? Now just subtract first. Okay, clear? As you can see, you will get definite integral. Okay, you will get what? Definite integral c to b fx. We just got this by using the theorem. Another thing, we are taking definite integral c to b fx dx can be rewritten as capital F of b minus capital F of c. Okay, we have three things. Okay, clear? We have three things. Simple. Now, as you can see, what is happening? If you add definite integration a to c fx dx to definite integration c to b fx dx, if you add them, if you add 2 and 3, what you will get? You will get definite integral a to c fx dx plus definite integral b c to b fx dx is equals to f of b minus f of a. Or okay, and f of b minus f of a is what? Definite integral a to b fx dx. Simple. Okay, let us move to property P3. Okay, now P3 says definite integral a to b fx dx can be rewritten as definite integral a to b f of a plus b minus x dx. Okay, P3. So substitute t is equals to a plus b minus x. This means dt will be minus dx. This means if x is a, then t will be b. If x is b, then t will be a. This means definite integral a to b fx dx can be rewritten as minus definite integral b to a f of a plus b minus t dt. Okay, clear? Okay, now using P1, you can write that it is equals to definite integral a to b f of a plus b minus t dt. Okay, now using P0, you can write definite integral a to b f of a plus b minus x dx. Okay, simple. Okay, now P4. P4 says definite integral 0 to a fx dx is equals to 0 to a f of a minus x. This means P4. So just put t is equals to a minus x. Just put t is equals to a minus x. Then dt will be minus dx. Now, if x is equals to 0, t is equals to a, then you will have, okay, if x is equals to a, then t will be 0. Okay, so now we will be doing the same process as in P3. Okay, and in of P5. Okay, clear. Now using P2, what you can get? Clear for P4. Now for P5, using P2, what you get is definite integral 0 to 2a fx dx can be rewritten as 0 to a fx dx plus definite integral 0 to 2a fx dx. Okay, now putting t is equals to 2a minus x in the second integral, this, okay, then dt will be minus dx. This means when x is equals to a, t will be a. When x is equals to 2a, t will be 0. Okay, now what you will get is definite integral 0 to 2a fx dx can be rewritten as minus definite integral a to 0 f of 2a minus t dt. Now using our properties, you can write it as definite integral 0 to a f of 2a minus t dt. This can be rewritten as integration 0 to a f of 2a minus x dx by using p naught property. Okay, I hope it is clear. So we showed that definite integral 0 to 2a fx dx can be rewritten as sum of definite integral 0 to a fx dx plus definite integral 0 to a f of 2a minus x dx. Okay, now property P6, proof for P6. P6 says that definite integral 0 to 2a fx dx can be rewritten as 2 times definite integral 0 to a fx when f of 2a minus x is equals to fx. So let's see. Okay, so it says that, okay, we already have this from P5. Okay, now if f of 2a minus x is fx, then this integration becomes 0 to a fx dx. You can add them. This will be twice of definite integral 0 to a fx dx. Okay, now if it is like this, f of 2a minus x is equals to minus of fx, then your definite integral 0 to 2a fx dx reduced to 0. Okay, clear. Now P7. P7 says what? Let me just show you. P7 says, P7 has two parts. First one says definite integral from minus a to a fx dx will be twice of definite integral 0 to a fx dx if it is if f is even. If f is odd, then it will be 0. Okay, now this means, okay, so you have what? Using P2, definite integral minus a to a fx dx can be rewritten as definite integral minus a to 0 fx dx plus definite integral 0 to a fx dx. Then just use t is equals to minus x in the first integral, which means this. Okay, this means what? The dt can be rewritten as minus dx. This means the change in limits will be, if x is equals to minus a, then t will be a. If x is equals to 0, then t will be 0. Okay, now also x t was equals to minus x. This means x is equals to minus t, the same thing. Now definite integral minus a to a we wrote as minus definite integral a to 0 f of minus t dt and definite integral 0 to t 0 to a fx dx. Okay, now first says that if it is even, this means f of minus x is equals to fx. This means this can be reduced to, first we'll be using the p naught property. Okay, and then using this fact you will get twice of 0 to a fx dx, this thing. Now for second, if f of minus x is equals to minus fx, then you can have that minus of definite integration 0 to a fx dx plus definite integral 0 to a fx dx. You will these both terms will be cancelled, you only left with 0. So your final answer for second part will be 0. Okay, I hope you got the proof how we did the proof. Okay, let's now use them. So evaluate definite integral minus 1 to 2. Okay, modulus x cube minus x dx. Now we know x cube minus x is greater than equals to 0 on this closed interval minus 1 to 0. X cube minus x is a negative, non-positive on closed interval 0 to 1, and it is non-negative on closed interval 1 to 2. Okay, now we will use P. What we will be using? P2 property. So using P2 property, my integration, this whole integration is now divided into three parts, which is definite integral minus 1 to 0, 1, 0 to 1, and 1 to 2. Okay, now this means just integrate them now. So as we know that in this interval this will be positive, so you wrote this. In this interval 0 to 1 this will be negative. Negative means minus extra sign will be there. It is positive in closed interval 1 to 0, so no sign change. Okay, clear. Now this minus we multiplied inside, you will get x minus x cube, as you can see. So just evaluate, this is simple integration. You will get x power 4 divided by 4 minus x power 2 divided by 2. The limits going from minus 1 to 0. Now x square by 2 minus x power 4 by 4, 0 to 1. X power 4 by 4 minus x square by 2, 1 to 2. Just substitute them or use the what? Second fundamental theorem. So you will get, applying 0 you will get this whole term 0. Now minus of applying minus 1 you will get this term. Okay, now applying 1 you will get this, applying 0 you will vanish this term. Okay, apply 2 you will get this, apply minus apply 1 you will get this. So after simplifying you will have 11 by 4 as your final answer. Okay, clear. Let us move to the next example. Now definite integral minus pi by 4 to pi by 4 sine square x dx. Just evaluate. So sine square x dx. So first of all observe that sine square x is even function. Now if it is even function, this means what? Okay, so first of all this is even function. Okay, now this means you just saw a property that integral minus a to a fx dx will be twice of 0 to a fx dx if fx is even function. So this is even function, so this indefinite integral can be rewritten as twice of integration 0 to pi by 4 sine square x dx. Now sine square x can be rewritten as 1 minus cos 2x by 2. This 2 will cancel this 2. You will have definite integral 0 to pi by 4 1 minus cos 2x dx. This integration is just nothing but x minus sine 2x by 2, as you can see. Now put the limits, you will get using the second fundamental theorem pi by 4 minus half of sine pi by 2 minus 0. Okay, you will get your answer as pi by 4 minus half. Okay, clear. Now problem example 30. Evaluate definite integral 0 to pi x sin x dx 1 plus cos square x. Okay, so use property P4. You will have what? So what we use? So sum, wherever x is written, you just replace sum minus x. Okay, so I will be same as definite integral 0 to pi sum 0 plus pi minus x. So pi minus x pi minus x, pi minus x. So this means this will be what? Sin x. This will be what? Also cos x. So you will have now 0 to pi, pi minus x sin x dx divided by 1 plus cos square x. Now what you have to do, as you can see, separate it. So pi sin x dx minus x sin x dx by this. This means after separating you will have pi multiply with a definite integral 0 to pi sin x dx divided by 1 plus cos square x minus I. We have I here, we have I, okay, on the left hand side. So take this I to the left hand side, you will get twice of I, which is equals to pi definite integral 0 to pi sin x dx divided by 1 plus cos square x. Okay. Now this capital I is equals to pi by 2 definite integral 0 to pi sin x dx divided by 1 plus cos square x. Okay, this means now you have to evaluate this thing. Okay, so now put cos x is equals to t, so that your dt will be minus sin x dx. Your dt will be minus sin x dx. Now change in limits will be, if x is 0 then t will be 1, if x is pi then t will be minus 1. So this means 1 to minus 1. Okay, now using the property p1 you will get what? This minus will interchange the limits. So pi by 2 definite integral minus 1 to 1 dt by 1 plus t square. Clear? Now this is what? 1 by 1 plus t square, your even function. So this means you will have 2 times of pi by 2 definite integral 0 to 1 dt by 1 plus t square. So again 2 will be cancelled. So you only left with pi multiply with definite integral 0 to 1 dt divided by 1 plus t square by p7. Okay, so this means, and you know that integration for this is tan inverse t. Now applying the limits you will get pi multiply with tan inverse 1 minus tan inverse 0. This will give you pi by 4. This gives you 0. This means pi multiply with pi by 4. This means pi square by 4 will be your answer. Okay, now next example. Evaluate a definite integral minus 1 to 1 sine power 5x cos power 4x dx. Okay, simple. First of all, see what your function is odd function. How? F of minus x is equals to sine 5 minus x cos 4 minus x is equals to minus sine 5 x cos power 4x is equals to minus of fx. This means what? F is your odd function. So whenever you have odd function, use what p7 part second, you will get this integration as 0. Okay, simple. Now next example. Definite integral 0 to pi by 2 sine power 4 divided by sine power 4 plus cos power 4x. Okay, now using p4 you will get definite integral 0 to pi by 2 sine power 4 pi by 2 minus x sine power 4 pi by 2 minus x plus cos power 4 pi by 2 minus x dx. This means definite integral 0 to pi by 2 cos power 4x dx cos power 4x plus sine power 4. Okay, now add them, you will get definite twice of capital I is equals to definite integral 0 to pi by 4 pi by 2 sine power 4x plus cos power 4x divided by sine power 4x plus cos power 4x dx, which means definite integral 0 to pi by 2 dx can be rewritten as x. Okay, now using second theorem, okay, second fundamental theorem of integral calculus, you will get pi by 2. Now I will be pi by 4. So your final answer will be pi by 4 for this definite integral. Now next example. Next example says definite integral pi by 6 to pi by 3 dx divided by 1 plus root 10x will be what? If you take capital I is equals to definite integral pi by 6 to pi by 3 dx divided by 1 plus root 10x. Okay, this means what we are doing, we are separating this 10 as sine by cos. So you will get definite integral pi by 6 to pi by 3 root cos x dx root cos x plus root sin x. By using p3 you will get definite integral pi by 6 to pi by 3 root of cos pi by 3 plus pi by 6 minus x. The same will happen here. you will get that this will be what your just sin x, this will be sin x, this will be cos x. Okay, this means what, as you can see. Okay, now if you add them, this thing and this thing, you will get twice of capital I is equals to definite integral pi by 6 to pi by 3 dx is equals to just x. Now using second theorem, you will get pi by 3 to pi by 3 minus pi by 6, which is pi by 6. Now divide by 2, you will get I is equals to capital I is equals to, or the value of definite integral will be pi by 12. Clear? Okay, now next example. Now a definite integral 0 to pi by 2 log sin x dx. This means take I, capital I is equals to definite integral 0 to pi by 2 log sin x dx. This means use P4. This means definite integral 0 to pi by 2 log sin pi by 2 minus x dx. This can be rewritten as 0 to pi by 2 integral log cos x dx. Now add them, you will get twice of I is equals to definite integral 0 to pi by 2 log sin x plus log cos x. You know, using the property of log, you will get what? Okay, so before using the property of log, we have to just add log 2 and subtract log 2. Okay, this gives you what? This gives you log. Using the property, you will have what? Okay, this will be multiply. So log 2 sin x cos x. Okay, so this will be sin 2x, log of sin 2x minus log of 0 pi by 2 log 2 dx. You can easily evaluate this. Okay, clear. But for this, for first integral, you have to do what? The substitution, which is 2x is equals to t. Okay, this means dt will be 2 times of dx. This means now change in limits will be x. If x is 0, t will be 0. If x is pi by 2, t will be pi. Now twice of I will be half of definite integral 0 to pi log sin t dt minus pi by 2 log 2. Okay, now 2 by 2 you will have by using P6. Okay, definite integral 0 to pi by 2 log sin t dt minus pi by 2 log 2. Okay, this can be rewritten as definite integral 0 to pi by 2 log sin x dx minus pi by 2 log 2 by by changing variable t to x. Okay, we just use what? P naught property. Now this is your what? The capital I. Okay, so this will be 2i is equals to capital I minus pi by 2 log 2. Okay, this means take this I to the left hand side, you will get I will be minus pi by 2 log 2. So your final answer will be definite integral 0 to pi by 2 log sin x dx gives you what? Minus pi by 2 log 2 as your final answer. So this is it for this property part of definite integrals. Okay, I hope you understood the proof, you understood how we used in question, in examples. The steps are clear to you. Okay, so if steps are not clear to you, please do it by your own. This will increase your ability to evaluate definite integrals as well as indefinite integrals. Okay, so this is it. Thank you. We will be back with more concept and the exercise part from this chapter. Okay, especially from the definite integrals. So again, thank you.